Dear students, today we will have further discussion about loop structure, and we will have another example that how we can discover the algorithm for loop structure and how it can be displayed and represented using pseudocode. So let's have an example of calculating the factorial. So you know that when I say factorial, what does it mean? So for example, if you want to calculate the factorial of 5, it means 5 into 4 into 3 into 2 into 1. So all of this you need to calculate the factorial, which is actually 120. So how can we write an algorithm using loop to calculate this factorial? You can see that there is a repetition starting from 1 from right side and going towards a number to the left side, and we are always multiplying the answer of the previous number with the current value of the iteration. So let's try to write the pseudocode of it using loop structure. So first of all, we can define fact, which is assigned initially the value of 1, and then we can say while number is less than equal to n, and n is basically for what we want to calculate the factorial, and in our case n is 5, and the number which we need to take at first starting before the loop is 1. So until then what we need to do is factorial is assigned by fact multiplied by number, and when the loop ends we can print fact. So let's try to execute it. Initially we have fact as a 1, so we have a RAM in which we have fact as 1 and number as 1, and we are saying that number is less than equal to n, which means 1 is less than equal to 5. So condition is true. What it is doing, fact multiplied by number, 1 multiplied by 1, and that 1 is again going to be stored in fact. That's fine. And then we should move this number by one value. Number is assigned by number plus 1, which we learned in one of the previous modules, that we should move the variable towards the termination condition. So next time this number will be 2. So then 2 will be multiplied by 1 and the result will be stored in the fact. So at that time the fact will have the value of 2. So let's do it over here. So at that time the fact will be 2 and number will be pointing to 3, and then 3 multiplied by 2, 6, that would be stored in the fact and number will be incremented further. So this 6 will be stored in fact and number will be 4, and this 6 multiplied by 4 will become 24, which will be stored in the fact and number will become 5. So let's do it over here. So now fact is containing 24 and number contains 5, and then 5 into 24 will become 120, and that 120 will be stored in the fact. So let's do it. So in fact we will have 120 and number will become 6, and then this condition 6 is less than equal to 5 will be false, and this will be end of the loop, and it will come over here to print the fact. And similarly you can add the definition at the start of this function to define it as factorial as we did previously. So if we summarize today's module, we have learned another example that how we can use loop structures and how we can calculate the factorial, and we have tried to understand the discovery of the algorithm, and we have written in it in the pseudocode format.